In today's episode, we'll be graphing quadratic functions in standard form. This comes from your homework worksheet 4.1. So let's take a look. We're going to do 3 problems. I'm going to start with number 9. For the following functions, A, tell whether the graph opens up or down, B, find the vertex, and C, find the axis of symmetry. So what we need to do is we need to take a look at a couple of things. To tell whether the graph opens up or opens down, we need to look at our A. And when I refer to A, I'm really talking about when you think about a quadratic, you can think about it in the form of y equals ax squared plus bx plus c. And therefore, our A, which is in front of our x squared value, can indicate whether we're opening up or down. Just like in an absolute value graph, the A, if it was positive, would open up, and if it was negative, open down. It's the same here. So here, my A is 3, my B is negative 6, and my C is 4. And my A will indicate whether I open up or down. So for part A, I know that my thing opens up because my A is positive. For part B, it says find the vertex. Well, in order to find the vertex, I really need to find my x value. And my x value can be found by using the axis of symmetry. So I'm actually going to do part C first, which is to find the axis of symmetry. That's that line that will go straight through the vertex, and then all points are reflected over that line. To find the axis of symmetry, I'm going to use the formula negative b over 2a. So I basically just plug that in. So in this particular equation, my negative b would be negative 6 over 2a, 2 times 3. If I calculate that out, I have positive 6 over a positive 6, which is just 1. So my axis of symmetry is x equals 1. Now to find the vertex, I can use this information. I know that x equals 1, and therefore I can find the vertex because I know that the x value of my vertex is 1. So I'm going to go ahead and plug x equals 1 back into the original function. So for part B, right over here, I can plug that back into the original function. In fact, maybe I might do that down here. So if I extend the page, okay, and then I go ahead and write my equation out. Y equals 3x squared minus 6x plus 4. And now I'm going to plug in my x to be 1. So I'm going to have y equals 3 times 1 squared minus 6 times 1 plus 4. Well, order of operations, my 1 squared goes first, so that's 1. So I have 3 times 1. Negative 6 times 1 is still just negative 6 plus 4. 3 times 1 is 3, and I have 3 minus 6, that's negative 3, plus 4 is a positive 1. So my y value I find is 1. So my b up here ends up being the vertex is 1, 1. I found my x by finding the axis of symmetry, and then I found my y by plugging in what I know my x to be to figure out what the y coordinate would be. So there, my final answer here is that it A, opens up, B, the vertex is 1, 1, and C, the axis of symmetry is the line x equals 1. Okay, let's take a look at the next problem. The next problem says graph the function. Label the vertex and the axis of symmetry. So let's go ahead and find the vertex and the axis of symmetry first to help do our graph. So we can use the same thing that we did in the last problem. We need to find our A, B, and C. And then we can find the axis of symmetry by using that negative b over 2a. So my a in this problem is the number in front of x squared, which is just a 1. My b in this problem, well, I have to look for the x value. Well, there is none, so I'm going to assume that b is 0 then, because 0 times x would be 0. And then finally c, which is my constant, is that 2. Okay, so now I can go ahead and find my axis of symmetry. Okay, it's negative b over 2a, and if I plug in my values here, I have negative 0 over 2 times 1. Now, negative 0 is just 0, and 0 divided by anything is still 0. So I find that my axis of symmetry is x equals 0. So the line x equals 0 is actually the same as the y-axis. It's a vertical line because all of our x lines go through the y-axis. So if I go to my tools here and I get out a line tool, let's make it red. Okay, and I'm going to make it a kind of a dashed line because it's just my axis of symmetry here. And we'll go ahead and do a dashed red line right through the x-axis, or the y-axis, excuse me. So this is my axis of symmetry, the line x equals 0. The next thing they asked me to do is then find the vertex as well. So now that I've found my axis of symmetry, my vertex should be easy because my vertex uses the x part of the axis of symmetry. So if my x is 0, I can figure out what my y is by plugging in x to be 0 into the original equation. So I'm going to go ahead and do that. I have 0 squared plus 2. Well, 0 squared is 0 plus 2 is 2. So my y value is 2. Therefore, my vertex is the point 0, 2. So I'm going to go ahead and graph that. I have 0, and then I have 2, and this is my vertex. My vertex is 0, 2. So I'm labeling both of those things. Now I have a parabola, so I need to get some other points here in order to graph this correctly. So I might make a chart then to figure out some additional points so that I can reflect them over the axis of symmetry. Okay, so here if I create a chart, and I have an XY chart here, some X's and Y's, I'm going to pick some X's and Y's that are on my graph. So maybe I'm going to pick, go ahead and pick 1. I'll do negative and positive. So if we do, well, I'll just do positive for right now. 1, I'm going to do 2 and 3. And I plug these in and figure out what my y would be. So 1 squared is 1, plus 2 is 3. 2 squared is 4, plus 2 is 6. And 3 squared is 9, plus 2 is 11. So here's some values, and I can start to graph them. So if I go to 1, 3, 1, 2, 3, and I put my point here, I can always reflect this point over the axis of symmetry. So I'm going to reflect it. It's a distance of 1 from the axis of symmetry, so it should be a distance of 1 in the opposite direction. Then I go to my point 2, 2, 6. So I go 1, 2, and 1, 2, 3, 4, 5, 6. And again, I can reflect this point over my axis of symmetry. So it's 2 from the axis of symmetry, 1, 2, and then I go 2 in the opposite direction, and I put my point. 3, 11, that goes off my graph. It's not really necessary, so I don't need to graph it. So then from here, I can draw my parabola. Okay, so I'm going to spare you the painfulness of watching me try to draw a parabola on this computer program. I think I probably spent the last 5 minutes trying to do it. But in the end, you graph it. It'll become a parabola. Go ahead and sketch your parabola.